Suspended in the dark reaches of the outer solar system, Saturn floats like a distant jewel, a gas giant wrapped in mystery, crowned with rings so bright, so vast, they can be seen from Earth through a simple backyard telescope. But those rings, they aren't just ornaments. They are evidence. Evidence of the unseen, of shattered moons, of gravitational currents invisible to the eye, of cosmic events written not in stone, but in ice, spread out across hundreds of thousands of kilometers. They are beautiful, yes, but they are also dynamic, changing, shifting, fading. And what they reveal about Saturn, about the solar system, about gravity itself, is more astonishing than we ever imagined. This is the story of Saturn's rings and the secrets of gravity they unveil. For thousands of years, Saturn was just a wandering light in the sky, a star that moved against the background of the others. But in 1610, Galileo Galilei turned one of the world's first telescopes toward it and saw something odd. He described Saturn as having ears. It didn't look like a sphere, more like a triple-bodied object. The rings, of course, were too finely spaced and his lens too primitive to reveal them clearly. It wasn't until 1655 that Dutch astronomer Christian Huygens, using a more powerful telescope, correctly proposed that Saturn was surrounded by a thin, flat ring, a celestial halo encircling the planet. What those rings were made of, and how they stayed in place, would remain a puzzle for centuries. Some thought they were solid. Others believed they were fluid. In time, scientists realized the rings are neither. They are made of countless pieces, ice and rock fragments, from dust-sized particles to chunks the size of mountains, all orbiting Saturn like a vast, shimmering disk. From a distance, they appear serene, but up close, they're chaotic, violent, a swirling storm of fragments caught in the grip of Saturn's gravitational field, a field that doesn't just hold them, it shapes them. The rings of Saturn aren't solid like a hula hoop. They're more like a cloud, thin, wide, and densely packed with icy debris. Over 95% of the material in the rings is pure water ice, some as clear as glass, some contaminated with dust or rock. The rest is made of silicates and organic compounds, leftovers from shattered bodies that once orbited Saturn. Altogether, the ring system spans over 280,000 kilometers across, wide enough to fit Earth comfortably inside. Yet they're incredibly thin, in most places, no more than 10 meters thick. If you could view the ring's edge on, they would nearly disappear from sight. But despite their size, their total mass is small, comparable to a medium-sized moon. If you compressed all the ring particles together, you'd get something no bigger than Mimas, one of Saturn's tiniest satellites. So how do such small objects maintain such a vast and precise structure? The answer is gravity. Not just Saturn's, but the intricate gravitational interplay of its many moons, some nearby, some embedded within the rings themselves. These are the hidden hands sculpting the rings into their intricate forms. Between Saturn and its rings live a population of shepherd moons, small, often irregularly shaped satellites that orbit just inside or outside the rings. Their names are as poetic as their roles: Prometheus, Pandora, Daphnis, Pan. These moons are like boundary enforcers. Their gravity tugs at nearby ring particles, keeping them confined, shaping sharp edges, and carving out gaps in the rings that remain astonishingly clean and well-defined. Take the Keeler Gap, for instance, a 42-kilometer wide lane in the outer A ring. At the heart of that gap orbits Daphnis, a tiny moon only 8 kilometers wide. But its gravity creates rippling waves at the edges of the gap. literal hills of ice particles, hundreds of meters tall, pulled up and down as the moon passes. Cassini also observed mysterious features called propeller-shaped disturbances, thought to be created by unseen moonlets, too small to detect directly, but powerful enough to alter nearby orbits. This is gravity not just as attraction, but as architecture. Each ripple, each gap, each spiral structure in the rings is a signature, the fingerprint of an invisible gravitational event. One of the most debated questions about Saturn's rings is also the most basic. How old are they? For years, scientists believed the rings must have formed with Saturn itself, over 4 billion years ago. But the more we learn, the more that timeline is challenged. Why? Because the rings are too clean. If they were truly ancient, they'd be darker, polluted with the constant bombardment of micrometeorites and cosmic dust. But they remain bright, pristine, ice-white. Cassini's data suggests the rings might be only 100 to 200 million years old, far younger than the planet they orbit. That's recent in cosmic terms. Think about it. Dinosaurs were walking the Earth when Saturn's rings may have first formed. So how did they appear? One possibility: a large moon or comet ventured too close and crossed the Roche limit, the point at which Saturn's tidal forces become stronger than the body's own gravity. The object shattered, and its icy remains spread into orbit. Another theory suggests multiple moons collided, creating a spray of debris that eventually flattened into rings. Whatever the cause, the rings may be temporary, a brief phase in Saturn's life. We're lucky to be alive at the same time they exist. Saturn's rings are not just a planetary feature. They are a microcosm, a living model of how solar systems form. The same physics that governs these rings, gravity, angular momentum, resonance, and accretion, also applies to protoplanetary disks, those vast clouds of dust and gas that form around young stars. In fact, many of the same structures have been seen in disks around distant stars: gaps, waves, spiral arms, all signs of newborn planets carving out space. In this way, Saturn's rings are a laboratory, a chance to study the birth of celestial systems in miniature. Through them, we learn not just how moons form, but how planets do, how solar systems evolve, how matter, given enough time and gravity, organizes itself into orbits, spheres, and eventually life. And it all happens in a realm we once thought was just decorative. Cassini's final orbits brought with them a sobering revelation. Saturn's rings are fading. Data showed that tiny ice particles from the rings are slowly being pulled into Saturn's upper atmosphere, drawn by electromagnetic fields and gravity in a process scientists call ring rain. Every second, thousands of kilograms of ring material fall into the planet. At this rate, the rings may disappear entirely within the next 100 million years, maybe sooner. To us, the rings seem eternal. But in the grand arc of cosmic time, they are a blink, a brief flash of icy light in a much longer planetary life. They had a beginning, and they will have an end. But while they last, they offer us something profound, a chance to witness gravity in action, not just as a force, but as an artist. We once thought the rings of Saturn were simple. Now we know they are anything but. They are dynamic, temporary, alive with forces we are only beginning to understand. They are records of violence, of balance, of structure born from chaos. In them, we find the fingerprints of lost moons and the equations of planetary creation. They remind us that beauty in space is rarely permanent, and that every shining arc, every icy ripple, has a story to tell. So the next time you look at Saturn, whether through a telescope or an image from space, Remember this. You are not just looking at rings. You are looking at gravity's masterpiece.